How can higher levels of facility standardization be achieved? In this presentation, you will discover opportunities related to standardization that our industry has been missing. You will also have a better understanding of the economic value of facility standardization. In addition, you will learn when and how to analyze and justify standardization, as well as how to achieve higher levels of facility standardization. Here to present their findings, please welcome Chris Catterall, Christina Trotter, Jinuk Choi, Ken Curry, and Tim Oakleaf.
Good morning. Is there anyone out there who does not believe that the upstream, midstream, and mining sector is missing out on opportunities related to facility standardization? Well, just wait till we get through with you. Other industries have accomplished high levels of standardization and modularization, and they have reaped substantial benefits. Aerospace industry, automotive industry, shipping. As for building construction, has anybody bought a home in a master plan subdivision in the last 30 years? Or been to a new chain fast food restaurant lately? As noted by Dr. Stephen Mulva in last year's annual conference, why no such gains in other industries? Meanwhile, project costs in the UMM sector continue to escalate, and that's putting our project economics in peril. While missing out on opportunities related to standardization is known to be an issue in other industries, our research team was sponsored by the upstream, midstream, and mining sector, so our research was focused on that sector. However, as shown here, this issue has been a recurring theme in CII for years, as evident by our brief research, and discovered that it was an unrealized opportunity by 6 other research teams. Specifically, Research Team 245 included a case study related to facilities related to low sulfur gasoline facilities, where facility standardization offered over $55 million in savings, which was 13% of total installed cost. However, I'd like to point out that as we're going to present over and over, this is not just about cost savings, it's very much about schedule savings related to reusing the same designs over and over again. Our research team feels that when all sectors understand these benefits, this is likely to change. Our research team was charged with responding to this situation by the UMM sector. We were fortunate to have a highly experienced and energized team with over 300 years of combined experience, most of whom had worked on multiple standardized projects. Our process included 1,200 hours of face-to-face and virtual meetings, and we utilized data from 90 surveys related to critical success factors and innovative technologies. For the record, we define standardization as shown. However, I'm going to pick out a couple of key elements. Consistency is critical. If you're not consistent in the way you apply those standardized designs, you haven't standardized anything. Alignment with stakeholders is obvious, and alignment with your project team is obvious, but paramount is management buy-in. Y'all know who you are. Optimization is the ultimate benefit, and you will hear us mention over and over again that this is not just about cost savings, it's about schedule savings. The essential question for our research is, how can higher levels of facility standardization be achieved in the UMM sector? Our research hypothesis and objective all supported this essential question. In response to this essential question, we developed a pyramid of solution pieces to increase standardization, thereby improving predictability, cost effectiveness, and agility. Our pyramid is comprised of the following levels: economics of standardization, standardization decision-making model, critical success factors and enablers, and innovative technologies. So let's start with the first of these decision pieces, solution pieces, economics of standardization. Take it away, Tim.
Thank you, Ken. We prepared our first solution piece, economics of standardization, to strengthen the understanding between the benefits and trade-offs of standardization and examine the lost opportunity in the upstream, midstream mining industry from excessive customization. As Ken highlighted, there are a lot of industries, automotive, the airplane and shipbuilding and commercial side, that have been taking advantage of standardization for years. Through our review, we will highlight the total installed cost, the life cycle cost, and the schedule savings that you can receive benefits from through standardization. Our case studies had 8 programs with 45 projects. Most of our programs had 2 to 7 projects, with one program having 17 projects. All of our projects came from the upstream, midstream mining industry, including gas transmission, oil and gas production and exploration, natural gas compressor stations, natural gas processing, natural gas liquids fractionation, and pipeline compressor stations. Programs that were initiated in 2017 are still ongoing. From this graph, we will highlight the cost spent by function compared to custom projects. On the x-axis, you will see the key functions of a project: engineering, procurement, fabrication, construction, commissioning and startup, and operations and maintenance. In parentheses below are the number of projects that were reviewed in the data set in the survey. On the y-axis, you will see the spent compared to customized projects, with the dotted line at the 100% representing the traditional customized project. Our case programs achieved 35% savings in engineering, 15% in procurement, 10% across the board in fabrication, construction, commissioning and startup, and operations and maintenance. I want to point out that the life cycle cost is the sum of all of these functions that you see on this graph, where the total installed cost is just the first 5. Overall, when you add all these up, the total installed cost savings was greater than 10%. That equates to millions and millions of dollars. When we evaluated the schedule duration by function, we saw the same result of savings in time spent in these key function buckets. We saw 30% savings in engineering, 20% in procurement, and 5% to 15% in the remaining buckets. Overall, significant schedule savings, which your companies can capture if you start standardizing your projects. As we evaluated the engineering cost savings, we found a constant trend of decreased costs per project as they completed each project in their program. Program 1 spent 100% with its initial project and got it down to less than 60% by their 7th project. Program 8 spent 100% on its initial project, and by its 3rd project was not spending any additional money on engineering and not re-engineering their project and just pulling the lever, going right to execution. You will see some of our program projects spent more than 100% on Project 1 to establish their program, but then immediately went into savings benefit mode as each additional project was completed. Here you can see the trend in schedule savings in our program projects, again showing that as each project was completed, additional schedule savings was achieved. Most companies spend 6 to 9 months in engineering on small projects and probably 12 to 15 months on large projects and mega projects even more than that. We had one project in our program that saved 19 months of schedule duration by executing standardization techniques. We asked our case study project programs this question: what were the life cycle cost savings and schedule savings achieved through their efforts compared to a customized project? From our data survey review, we achieved 25% savings in life cycle cost and 15% schedule savings. If you would like to capture those benefits for your company, raise your hand. Here is a list of the standardization benefits. Our research team reviewed Research Project 283 modularization, which established 10 benefits and 3 trade-offs with their research efforts. We added 3 new standardization benefits and 3 trade-offs. The 3 new ones were accelerated response to schedule needs, reuse by relocation of existing assets, and decommissioning cost savings. The learning curve benefits that we've seen are in fabrication, module installation, site construction, operations and maintenance, and commissioning and startup, as well as procurement discounts from volume and/or early commitments, O&M material management cost savings, and volume or early commitment in terms of management cost savings on construction materials. We surveyed our case programs and found that the top 3 benefits identified were design and procurement in advance, design wants, reuse multiple times, and accelerated response to schedule needs. So what are the trade-offs and barriers to standardization? The 3 new trade-offs that our research team added was the susceptibility to changes in market conditions, changes in environmental regulations and fiscal policies, community concerns, and lack of competitive bids. We also acknowledge the sacrifice benefits from conventional execution. Again, we surveyed the top 3 trade-offs, and they were the changes in market conditions, the time to establish the initial project, and the initial design standard. Don't let this discourage you. All of the projects that we're talking about today have gone through this process of establishing the first project, and most companies will spend 3% of their total installed cost to establish their first project. And if you just ask the right questions of your stakeholders and get alignment early, you can capture the benefits of standardization and pick out those pieces that add value. Some programs started with their long lead equipment and strategic modules, freezing their plot plans, ISBL, to where they could capture those benefits time and time again. Obviously, infrastructure and supports to locations may require some engineering, but there's a lot of value and opportunity in your projects to standardize. So as you can see, with 25% life cycle cost savings and 15% schedule savings, the benefits outweigh the trade-offs. In summary, our program projects met to exceeded expectations in cost effectiveness, agility, and predictability, as well as safety, quality, and schedule. And now I'm going to turn over to Chris Catterall, who's going to talk about the program projects in more detail. Chris?
Thank you, Tim. So I'm going to spend the next couple of minutes talking about 4 of our case programs. This first one is dear to my heart because I was the I&C engineer that was on this project. So the client come to us and said, our well pads cost way too much. We're going to standardize. As engineers, we all, okay, how are we going to do this? So the design team looked at the well pad, and we decided we can componentize different components on a well pad and create design packages, standard design packages for each one of these components. Basically, play it like Lego. So we created 7 components: the wellhead, the end piece, the high line, the coupler, the equipment skid, the flare, and the riser. And like Lego, it was a plug-and-play design. This is an example of a single well site design, which uses 5 of the 7 standard components, which essentially means that they had 5 standard design packages, and they had the MTOs and everything for. This was an example of a 12 well site configuration, which, as you can see, used all 7 components. This particular program underwent 3 generational design changes. And what I mean by generational design changes is, on a yearly basis, they would take the lessons learned from the projects previous executed in that year, and a committee would get together and look at the lessons learned and decide which ones they were going to implement for the next year of projects. As you can see, at each generational change, there was significant savings on total installed cost per well and engineering cost per well. And by the end of the 3rd generation, we had saved 57% of total installed cost, which equates to, when we're looking at about $1.1 million per well originally, we were down to $440,000 per well by generation 3. So, when you're talking about a 12 well pad, that is substantial, millions and millions of dollars in savings, and engineering was down to $86,000. The next case program that we looked at was a compression program for transmission lines. This one, again, had the 3 generational design changes to it, and 17 projects executed under this program. When the design team, or when the research team, looked at the engineering hours and costs, the project management costs, and the procurement costs on this program, it equated to 50% savings in hours and 50% savings in total installed cost, which relates to $8 million in savings. Who doesn't want that? The 3rd program was a program in Upstream. It was basically for an oil gas separation facility. The design team kept on asked the same question: how many times are we going to design the same thing without realizing the benefits of standardization? So they used various standardized components, and throughout the program, they were able to achieve 20% savings in engineering, which relates to 2% cost savings in TIC, a 7% savings on procurement and construction labor of TIC, and through efficiencies gained, they were able to have a 5% improvement on finding and development costs. So basically, they knew where to put their facilities out in the field. This program was so successful for the customer that they are now implementing standardization on other facilities such as central tank batteries, compressor stations, pump stations, and saltwater disposal wells. The 4th case program was another natural gas compressor station program. This one had 7 standardized projects in total. As you can see by this graph, and the key point that I want you to take away from this graph is you don't always see the savings right away. And this is key when you're having those stakeholder alignment at the beginning of a program, because a lot of the executives just assume if they standardize, they're going to see cost savings right away. Well, as you can see on this, it took to project 4 before they could actually achieve any cost savings. But even though this program didn't see substantial cost savings in total, what it did is it gave basically schedule certainty. And that was key to this owner. Our research team also looked at what were some of the key obstacles on the projects and why didn't they achieve full standardization. Here are listed of the main reasons. A change in leadership. So again, you lose the commitment at the upper levels to maintain the standard and invest. A change in the project manager. Again, a new project manager comes in, doesn't understand why you're standardizing. A change in the project team. A change in the scope. That always puts a wrinkle on any project. A change in vendor supplier. Or if you implement it in a different region and all of a sudden you're implementing the standard in Canada and you bring it down to Texas, it might not necessarily work. And then a change in operation and maintenance teams, because they are the ones that have to maintain it, and if they don't believe in the standard, they're going to tweak and put that piece of gum that the colonel said yesterday. So this will, I'll now turn it over to Christina, who will take in the next solution piece on economic, or decision-making model.
Thank you, Chris. So I'll present our next 3 solution pieces. And the second one is a standardization decision-making model. And this is a software tool that the team built to help you if you're on the fence, maybe we should standardize, maybe we shouldn't. It's kind of similar to PDRI. It gives you a guiding indicator, and we really think you're going to like this. So there are 2 levels to the tool, to the assessment. There's an FEL 0, 1 type of assessment that we call the level 1 assessment. This is very early on. You have an idea, you just want to ask some high-level questions, get a feeling, and then we recommend you bring the same group of people back and do the level 2 assessment in FEL 2 or FEL 3. Again, just to kind of get an indicator, should we standardize or should we not? So these are some of the questions that we ask in the level 1 assessment. And I'm not going to go through all of these with you, but I did want to touch on a couple so you kind of know what we're asking. So one of them is management commitment to standardization. Do you have that alignment and approval that we've been talking about? And remembering it's a long duration. If you're building 7 projects, if you're building 12, that's going to be years, right? So you need that commitment for the long term. We ask about degree or level of standardization. Are you standardizing some of the pieces and parts, like in the Lego example? Or are you standardizing the entire footprint? Or is it the entire footprint except for the foundation? So how much are you standardizing? And then, of course, we ask number of standardized projects. Are you building 1? Are you building 5? Are you building 50? Because that's definitely going to influence your decision. And then marketing, making sure you take a minute to ask and say, is a standardized design what my company really needs or what my client really wants, and making sure that you are on the right track. So this is a screenshot from the tool. You don't have to read it, not an eye test, but we just wanted to show you what it looked like so when you get it open, it looks familiar to you. So we'll take a look at an example from the level 2 assessment. So again, level 2, in a little more detail. So what you do is for each of the categories, you assign a weight to say what's important to you. So you ask questions like, is cost more important than schedule? Or is schedule predictability really what I'm trying to get? Or project location, are my locations fixed or do I have some flexibility in where I'm building my pump stations or whatever? And then things like suppliers and contractors. Is that a key part of your design solution or not so much? And again, this would be on the first project of a suite of projects. You're not going to do this every single time you do a project in a program. So once you've assigned the weights, you go through each category and you read the description of the indicator and of the factor. And you do this as a group, again, similar to PDRI. And if you hover over each of the descriptions, we've provided a few more items to consider. So we're really trying to set you up for success here. And once you read it, talk about it as a group, then you will assign a rank. And it ranges from strongly favors customization to strongly favors standardization, again, with the magnitude of the score indicating the relative strength. So you go through all of these in all of the different categories, and at the end, it will give you a composite score, a negative score indicating that you should customize, negative isn't bad, and a positive score indicating that you have a strong candidate for standardization. And the magnitude of the score gives you the relative strength. So, quick story. We built the tool, we wrote all the descriptions, and of course, we as a research team were very enthusiastic about standardization and all for it. We started validating this tool against actual projects, and we started checking it against projects that should be customized, one-of-a-kind projects, and we did not get very good scores because we had written so much bias into the descriptions. So the team stopped, we rewrote a lot of the descriptions, and we validated it against multiple projects. So if you have a project that should be customized, we'll get a customized score. So that was a good wake-up call for all of us, but really helped us validate this tool. So in addition to a score, we're also providing you lists of extremes. So these are the 10 factors that you ranked that most strongly favor standardization and most strongly favor customization. So this just gives you a chance to look at some trends, look at how the group ranked things, just to see maybe there's an opportunity for you. So this is the software tool we built. If you get nothing else from this presentation, please remember this tool. We think you're gonna find it really handy. Again, not an end-all be-all, but if you're on the fence, this should help push you one way or the other. Okay, so our third solution piece is what we're calling critical success factors and enablers. And this is for when you have decided to standardize, you're gonna jump right in, and you wanna get the most out of it. You really wanna improve your agility, your predictability, and your cost effectiveness. So the team started with 92 critical success factors. These came from literature, from surveys, from the expertise of the team, but we got it down to 15 critical success factors. And again, I'm not gonna get into all of these because for a presentation, 15 is still a lot. So we did a survey and we said, okay, which of these critical success factors will have a high impact on standardization, but currently have very low implementation? So where can industry improve right now? And we got it down to these 4. So alignment and approval, very consistent theme here. Discipline to maintain standardization. That once you start a program, you will see it through, even with staff changeover. And then defining your approach. Again, making sure it's written, making sure you have a clear plan that is communicated all across the organization to really get the most out of it. And then constructability of standardization. This is a great one because this is saying more than just the design. If I have a repeatable thing that I'm building, can I standardize my subcontracts? Can I standardize the way I bid it? How can I take standardization and go even farther than design all the way through construction and commissioning? So those are the 4 where we really can jump on these right now. So we took the 15 critical success factors and we started asking, okay, who is responsible for these and when? And we took the results and we plotted them on a graph. And I'm not showing it to you yet because I want to explain it first. So on the y-axis, we have the who. This is who is responsible. So the owner along the top, contractors in the middle, and vendor and technology licensors along the bottom. And then on the x-axis, we have project timing. So FEL 01 through detailed design, through operations and maintenance. We took each of the critical success factors and we put it on this chart. So I'm gonna show you the data, but don't try and make too much sense of it. Just look at the density. Look at where these are popping up. So we're trying to answer the question of who and when, and we see a lot of these are very early, and they are really the responsibility of the team, but a lot of them sit with the owner as well. Okay, so before you get carried away, this is the same information, just back in a very comfortable pie chart. So on the left, we have the who. So again, you'll see more than 50% of these critical success factors need to be initiated by the owner. And then on the right, we have the when, and more than 50%, again, are prior to detailed design. So if you're partway through detailed design engineering on your first project of many, you've kind of missed out on the chance to really squeeze every last dollar and every last day out of standardization. So not to discourage, but we're trying to answer the question of who and when, and it is early and as a team. So for each of these critical success factors, once you've jumped in, you're excited about it, you want to learn more, the team has provided enablers for each of the 15. So it has the who, the when, and it has 5 or 6 actionable items for you to take a look at and do to really get the most out of standardization. Okay, so our fourth and final solution piece is innovative technologies and management approaches, and this is the very forward-looking piece of the research. This came from literature, again, the experience of the team, a lot of different places. We found 27 innovative technologies and 12 management approaches, but again, it's kind of a lot for a presentation. So we did a survey and we said, what is gonna have a high impact on standardization, and what has a high likelihood of happening in the next 5 years? So for the innovative technologies, that was these 6. And some of these should be super familiar. Modularization, mobile user interface devices. We've all heard Noe talk about the app for 2 days. So we know those. And then a little bit more forward-looking, construction simulation technologies, intelligent automated data collection, LiDAR, that's definitely a stretch. But remember, 5 years. So depending on the size of your capital project, that may be 2 projects away, 3 projects away. So keep an eye out for a chance to use these. They are coming and they're coming quickly. So then we did the same survey with our 12 management approaches. Again, high impact and a high likelihood of happening within 5 years. And we got it down to these 5, all themes that you have seen throughout this presentation. Commitment to having an experienced team, alignment, discipline, having a culture that supports standardization, where everybody's willing to work together, everybody sees the benefit. But I did want to touch on this last one, which is having a formal lessons learned policy. So Chris gave an example of a project that had generations. This is having a formal structured process for documenting, if you're building, say, 6 projects, taking the first 2, documenting your lessons learned, maybe tweaking the design, maybe tweaking the construction approach, and then adjusting that back into the program. So that I just wanted to touch on just a little bit. So those are the 4 solution pieces. We've given you a lot of ammo, and I'm going to hand it to Jen to wrap it up.
All right. Thank you, Tim and Chris, for sharing the economics of standardization. And thank you, Christina, for sharing the 3 other solution pieces. This is the pyramid for industry use to increase standardization, thereby increasing predictability, agility, and cost effectiveness. From our case studies, you should be able to determine how you or your company can save costs and schedules. Also, from our presentation, you should be able to learn how you or your company can achieve higher levels of facility standardization. For those of you who like to learn more, there are more details and case programs that we could not share in this presentation due to the time constraints. However, we'd like to invite you to find our knowledge base for more. Now, ask yourself this question. Is the industry missing out on opportunities for standardization? Today, we have provided you the answer to this question. Through standardization strategy, the industry can save 10% of total installation costs, 25% of lifecycle costs, and 15% of schedule. This is awesome, right? We hope you're excited as we are, and we hope that when you go back to your company, discuss with your colleagues, and consider implementing standardization strategy for your future projects. Today, we have provided you the 3 user-friendly tools to help you achieve higher levels of facility standardization. Those are standardization decision-making model, critical success factors and enablers, and innovative technologies and approaches. Remember, for successful execution of standardization, owners and contractors need to be aligned and involved early. And of course, maintaining standardization philosophy throughout the lifecycle of project is critical. Lastly, we'd like to thank CII and the UMM Sector Committee for their support over the past 2.5 years. We also like to thank them for continuing their support for additional year for our next phase of our research. In the next phase, the research team will develop a new standardization work process that helps the project teams to execute the standardization strategy successfully, thereby exploiting maximum benefits of standardization. Currently, the research team is looking for a few more participants for our next phase of our research. If you're interested in joining us, please find us. It's the pyramid sticker on our name tag. Or after this presentation, please stop by our booth. And remember, always you can find more from our knowledge base. Now, this slide concludes our presentation. Now, we'd like to open the floor for questions.
I think I'm doing any time.
Yeah, we got a couple minutes.
Okay, so a couple of minutes. Okay, so first of all, remember this. See that sticker? Find one of us out there in the Innovation Showcase. I got a bunch of questions, so I know you guys want to talk. So one I will try out. How can you, Tim, how can you best initiate standardization culture in your company when employees' brains have been wired to customize per project needs and scope?
That's a great question, Ken. I would encourage the companies in this situation to use that project to challenge your commercial and management teams to ask the right questions early and capture those standardization opportunities. So the culture is going to change through the process of front-end loading and developing your project, and the team recognizing where the value is and confirming that when you make those decisions, it's going to meet the business objectives. I've seen a lot of teams that they get caught up in where we build in a 125,000 barrel a day frac or a 75,000 barrel a day. There's a number that's going to meet your company's objectives, and you can standardize on it and then just keep executing that and not get in the mode of changing your equipment sizes and your plot plans time and time again. Ask the questions early and lock them in.
All right, I'll do one more. How do standardization and modularization relate to each other? I think that's a Chris question.
Yeah, so I'll take that question. In my opinion, they're key. Anything that can be standardized can be modularized. You know, it's all about safety. It's removing the man hours from the field. So in a couple of case studies, most of the designs were all modularized, built in fab shops, and then delivered to site. It's easier that way. You start small. You know, you start at the component level. It's easier to get commitment buy-in from your alignment stakeholders if you start small, and so it's easier to modularize the smaller components.
Let me ask one last question. Okay, there were 3 or 4 related to this, so I'll boil it down to one. Does standardization stifle innovation? That may be a Christina question.
So no, because there's innovation in more than just the design. There's a lot of innovation in how you do your work and how you get your designs to the field. I I'm an engineer, so I can say this. Sometimes you have to keep your engineers in check because you have to resist the desire to make it perfect every single time. It's going to be a little too small or a little too big, but what you're getting is time to market. So my diplomatic answer is no, it doesn't stifle innovation because innovation happens in a lot of different ways. And again, if you do a lessons learned, you improve your design every few generations, whatever that may be, you will get those improvements, you will get that efficiency you're looking for, but it may not just be pure engineering innovation. Okay?
Thank you very much.